me because it was really hard uh, uh, for me to understand at the first time. So that's why I wrote this topic, but I didn't have the time to publish it because it was really unfinished. It needs more description to finish it up, but I didn't have the time. So rather than finish up the blog, I'm just going to give you the overview how to work with pointers. So if you don't know about pointers or really confused that what it does, it's the session for you. So let me just start with very basic concept. So here I have a few variables. So let me just remove those. Okay, so I have few variables. Let me add a new pointer, int, and we're saying it as pointer. That's it. So when you declare a variable with a star, it means it's a pointer. It points to something. So a pointer typically has a 2 bytes of space, 2 bytes, which points to a memory location of your RAM. So if I open my RAM, you can see that there are 4 GB of space is already used. So when I declare a pointer, it creates a 2 bytes, takes a 2 bytes and points to somewhere in the memory of my RAM and works with it. So currently when I just declare it, it's a null pointer. Even though it's a null pointer, it took 2 bytes. It's important. So a null pointer, a regular variable always takes the space as it needs. So an int as a regular variable will take 4 bytes of space. A character of a regular variable will take 1 bytes of space, 8 bits. However, for the pointers, it's not really based on the type when you have a null pointer. So whether you choose character, whether you choose int or unsigned long, it will first take 2 bytes as an additional space, and which will be a null pointer, and then when you ask for new memory space, it will give some it will point to some another new free memory space. So that's the concept. Whenever you open a program, if it has variables, those variables will be created in your free memory space. So the standby memories are the memories that OS are ready to give you when you ask for them. So based on the concept, you have some grasp now. So to make it simplify more about pointers, you can think of pointers as an array. It's not the same thing, but for now, simplicity, if you understand array, it's mostly similar. In an array, what you have done is, let's say, an AB. If it is an array, you just say AB and 10, and in C program, it gives you 10 sequential integers in memory location, sequential. So the pointers concept is it's null, but you have to define it to give you some memory location from your RAM. So let me declare it. So we're working with C. For CPP, it's different. It's much more easier actually. So we have to use malloc. So write the function malloc, and malloc function returns a pointer type. So you must cast it with your specific pointer type. So in C, if you are confused with the data type, what you can do is use a void pointer type, and that's what this function does. It returns a void pointer. To get to your pointer, you must use your specific data type. So we want a pointer based on integer type, so that's why we're giving int pointer. That's it. And in between, you write the size. And if you say 1, it will take 1 memory bytes in your RAM, means 8 bits. If you say 2, it takes 2 memory bytes in your RAM. So if it fails, it gives you a null pointer. That's another conclusion of this function. So let's say I want a 5, let's say 10. I want this array type into this pointer. So what I can do is, let's say 10 into, I know the size of int, but what you can do is use the method of size of and write your data type. So no matter what data type it is, so if you're looking for char, you just put a char. So I know int is 4, so I could replace this with 4 and it will give me, let's say, 4 into 40 bytes of memory space sequentially in my free or standby memory locations. I think size of is better than writing strongly typed values like 4, because you don't have to know the size of the data type in whatever system that you are running the program. So that's one better concept. So another thing about the pointers, let's say I want to access these pointers. Let's say I want to give a value to my pointer. Let's say I want to access, let's say, first memory location of my pointer. So what I should do is write like this, plus 0. That's the concept. So if you want to access, let's say, second, assume that it's an array. So 0, 1, 2 sequential indexes. So if you want to access the index 1, or put the value into 1, you could write like this. So first we're going to go simple. It will all make sense. Just bear with me for a few minutes. And if I fail, give me a dislike. So let me just write the printf. Since we have just one value, I'd like to just print that value, index 1, which is item 2 actually. /n, let me run it, and of course you will see 2. So let me write 5 just for fun. Okay, so you can see that it's showing that 5. So that's how you assign a value to a pointer. And as I said before, that you can simply think of the pointers as an array. So what you can do is write like this. It will still work same. So you can think of the pointers as an array when you have sequential pointer, but for simple pointers, let's say single variable pointers, it doesn't work like that. So we'll get to it. So let me just run it. As you can see, that same value. So couple of things happens in the pointer. So let me just write the previous one again. You can see there is a star mark. When you are giving the star mark, it means that you are looking for the value or assigning the value to the pointer when you are giving the star. So when you're giving a star in front of a pointer, it means you are acting it as a simple variable. However, when you don't have the star, it acts as the memory location value, memory location value. So the pointer will give you the first memory location of your free space, or where it is pointing to. So let's say if it is pointing to, let's assume that my pointer is pointing to, let's say, 500 memory location. That's the first free space that we got for our 10 arrays. So let's say this is the memory address or RAM address for simplicity. So when you are asking for pointer, it will return only 500. And if you try to assign a value with the with address like this, you'll face an runtime error, because you cannot assign a value to a pointer like this, because memory locations should be came from the RAM or the programming system. You don't have to assign it. And when you plus it with something, it means that go to the next sequential block. So since it's an int type, so it will go like 4 bytes apart. So it will not go like a half of a integer or half of a character, something like that. So whatever data type that you have defined, it will go that sequence manner. So if you understand so far, we're good to go. So let me give you another example which is very useful. So like this, let's say we're getting the pointer value first. However, the pointer also exists in the memory location, as we said. That when you declare a pointer, it takes 2 memory bytes. So where it takes somewhere in the memory. So first it takes itself in the memory, and then it points to something. First it takes to itself and then points to something. So when you write like this, and so it will give you the memory address that where it is actually situated, or where it is actually placed in the memory. And when you are saying that pointer, it gives you the location of the memory that where it points to. That's 2 key things. So that's and that's a non-and pointer. So let me show you what it does. As you can see, 2 different locations. So first one is for itself, and the next one where it's pointing to. Okay, another good example would be like this, that where the first index or 0 index is pointing to. Pointing index of 0, let's say. Okay, so 0, we're giving it 0, so you'll see that these 2 should, okay, so these 2 should give the same result. As you can see that we're just adding 0, but let's say we're also interested in the next sequential address. So +1, index 2, item 2, index 1. So let's see. Okay, so where do mistake? Okay, so I have terrible cold, so sorry for that. Okay, so as you can see that these 2 locations are same because this is pointing to this first index. So and the next index would be the sequential of the 4 bytes. So if you add the 4 bytes, you will have next index. So that's where it's pointing to. And if you want to save a value to that address, what you can do, just put a @ So far, so good. If you understand so far, half of the concept of the complex and basic pointers are done. So another simplest example I will take. So another problem that students face with the pointer is declarations. So sometimes you're going to see that some people declare pointers like this and some people declare pointers like this one. So how do you know that when a star is given, should you write the star here or no stars? So at your first declaration point, you have to think about this total as a data type, not just int, but int plus star or asterisk as your total data type. So whenever you try to declare a pointer, declare a new memory, you should always do it with pointers, not with a star. Star means you are assigning a value, and without a star means you are pointing to somewhere, and you can do it by malloc or alloc or something like that. There are a lot of functions. So that's the concept. So students really face a lot of problems if you still think that it's not clear, mail me. But I think some future few examples will make a lot of sense. So let me start with another example. Let's say I have a pointer, let's say star of p, simple pointer. But now, rather than creating a new memory location, I'm going to point to an existing memory location. So we have several variables here, right? So let me just give you some values. Let's say 190, or let's say give it 240, and let's say give it 530. Different values, which will make sense. So let's say I have a pointer and I'm pointing it with p. You can declare it like this one. This one is fine, or you can also do this one. You just declare the pointer and you say p equals, p requires address. In C or C++ programming, in order to get the address of a variable, you write and the variable name. So in this case, if I wanted to point to the x, I write x. So now it points to x. Another way to do it is up here. These two are same thing. However, declaring star p and x is not the same thing. When you're referring to star p, it refers to the variable itself. When you're giving star p, it means you're referring to this variable. When you are saying p, it means the pointer where it points to, and it points to the address of x. Okay, for simplicity, we're going to print out the addresses here so that you understand. So and of x and p, so and of x and p. So you'll see that both addresses are same. Now let's say change of x. Let's say I change somewhere, let's say 10,000. That's simple. Now if I print pointer value of the pointer, so if you remember from my previous telling that when you just give a star p, it means the variable itself. However, when you are just saying p, it means that you are referring to the pointing location or memory address location, that where the very pointer is pointing to. So if I print p, you will see the value of p is now 1000. Again, let's say we change p, star of p, let's say 800. So previous one I mistakenly said 1000, it would be 10,000. Printed 10,000 because it's pointing to x. Pointer p is pointing to x, and now would be a very good time to make our another branch so that you could see that what we have done so far. So let's make another branch, working 3, and we're saying it pointer for single variable. Okay, so now if I print those, let's say print of x again. Now these outputs will make all the senses about the pointers. So let me just run it. Now you can see that x end of x is this value, and pointer value is also same because they are pointing to same location. We haven't changed pointer value, but we have changed the value of x here, but we're printing pointer. As you can see that the value of pointer is changed because pointer p is actually pointing to x, whatever value the x is or whatever the value inside that location, it's just giving it back. That's it. And whenever I change the value, so remember, if you want to change the value, just put a asterisk sign and the pointer name and equal. value. So it should, I'm changing the value to 800, and now I'm printing P, and then again I'm printing X. Both are 800 because both are pointing to same location. I don't know how much I can make it simpler, but I think that's the portion make me understand about pointers. So far so good. That's for the basic stuff, and I will give some time to write some documents, scan it, and give you some images, so how the pointers work. So there are a couple of things that you still need to know, like as clearing the memory and something like that. We'll be talking about those in the advanced section. Thank you.